Hello, and welcome. As the world outside grows quiet and the day's thoughts begin to fade, allow yourself to settle into a place of comfort and stillness. Wherever you are, I'd love to know the time and place you've chosen for this journey. So please feel free to leave a comment below. And if you enjoy this time we spend together, be sure to subscribe so you are notified of future stories. Tonight, our journey takes us to a place of silent, silver beauty, a constant companion that has hung in our sky for all of human history. We will drift through the vacuum of space, across the dark, tranquil seas, and into the ancient, shadowed craters of our moon. As you relax and prepare for a deep and restful sleep, we will explore its story together, weaving a tapestry from 100 of its unique and fascinating truths. Let your mind become weightless as we leave the familiar world behind and travel across the void to a world of dust and dreams, of violent origins and quiet, timeless wonders. Our story begins not on Earth, but in the vast, silent darkness that surrounds it, with a companion that has shaped our planet, our history, and our very biology. The moon, Earth's only permanent natural satellite, hangs in our sky as a constant testament to the intricate and violent history of our solar system. For millennia, it has been a source of wonder, a beacon for travelers, and a driver of myth. But science has revealed a world far stranger and more complex than any legend. While it may seem a mere stone in the cosmic ocean, it is a celestial body of significant stature. Among the hundreds of moons orbiting the planets of our solar system, it ranks as the 5th largest. Its diameter spans an impressive 3,475 kilometers, which is about 2,159 miles, a scale that makes it larger than the dwarf planet Pluto. This considerable size grants it a commanding presence, not just in our sky, but in the gravitational dynamics of our local space. But its size is not its only distinguishing feature. Its composition tells a tale of a fiery and dense past. When we measure the density of the solar system's moons, our moon is revealed to be the second densest of all, surpassed only by Io, Jupiter's fiery, volcanic moon. This high density suggests a body rich in metallic and rocky materials, with a relatively small core, a clue that points directly to its cataclysmic origins. This dense, massive satellite is locked in an intimate gravitational embrace with our world, an embrace so tight and so ancient that it has fundamentally altered its behavior. Over billions of years, Earth's gravity has tugged on the moon, slowing its rotation until it reached a perfect equilibrium, a state known as synchronous rotation, or more poetically, tidal locking. The consequence of this is profound. The moon now takes exactly as long to rotate on its own axis as it does to complete one orbit around the Earth. This gravitational dance means that it always presents the same face to us. A familiar landscape of dark Maria and bright highlands that has been gazed upon by every human who has ever lived. The other side, the far side, remained a complete mystery until the dawn of the space age. This constant presence in our sky is deceptively bright. On a clear night, the full moon can illuminate the landscape, casting sharp shadows and appearing like a celestial lantern. Yet this brilliance is an illusion, a trick of cosmic lighting. The surface of the moon is, in reality, incredibly dark. Its reflectance, a measure of how much light it bounces back into space, is comparable to that of worn asphalt. It shines brightly only because it is set against the infinite blackness of space and is illuminated by the unfiltered, ferocious light of the sun. This leads us to one of the most beautiful and improbable coincidences in our solar system. From our unique vantage point on Earth, the moon and the sun appear to be almost exactly the same size in the sky. This is not because they are remotely similar in scale, but because of a perfect celestial alignment of size and distance. The sun is approximately 400 times larger than the moon, a star of truly colossal proportions. But it is also, by chance, about 400 times farther away. This precise ratio creates the spectacle of a total solar eclipse, where the moon's disk slides perfectly over the sun's, obscuring its brilliant face and revealing the ethereal glow of its corona. This delicate balance, however, is not permanent. The relationship between the Earth and Moon is a dynamic one, still evolving over geological timescales. The same tidal forces that locked the Moon's rotation are also causing it to slowly drift away. The Moon is receding from us at a rate of about 3.8 centimeters, or roughly 1.5 inches, annually. As it moves farther away, it pulls on Earth's oceans, transferring angular momentum from our planet's rotation to its own orbit. This process is infinitesimally slow, but its cumulative effect over eons is staggering. Earth's days are gradually getting longer, and the Moon is spiraling ever outward. To understand this strange and wonderful object, we must travel back in time to the chaotic birth of our solar system some 4.5 billion years ago. The most widely accepted explanation for the Moon's existence is a narrative of unimaginable violence known as the giant impact theory. This hypothesis proposes that a young, still molten Earth was struck a glancing blow by another protoplanet, a body roughly the size of Mars. This hypothetical impactor has been given the name Theia, after the Greek Titan, who, in mythology, was the mother of Selene, the goddess of the moon. The collision would have been cataclysmic, vaporizing Theia and a significant portion of Earth's mantle, and flinging a colossal cloud of molten rock and superheated gas into orbit. Over time, this debris coalesced, drawn together by gravity. eventually forming the dense, rocky sphere we now know as the Moon. This violent birth explains many of the Moon's peculiarities, including its density and the composition of the lunar rocks brought back by the Apollo astronauts. The gravitational influence of this cosmic child on its parent planet is relentless and profound. Its pull is the primary driver of Earth's ocean tides, a twice-daily rhythm of rising and falling seas that has shaped coastlines and ecosystems for billions of years. As the Moon orbits, its gravity tugs on the water, creating a bulge on the side of the Earth facing it. A corresponding bulge also forms on the opposite side of the planet, a consequence of inertia and the differential pull of gravity across Earth's diameter. As our planet rotates beneath these two bulges, we experience the familiar cycle of high and low tides. But the Moon's tidal influence is not limited to our oceans. Its gravitational pull is so immense that it deforms the very planet itself. Few people are aware that there is also a tide of rock, a subtle but measurable warping of Earth's solid crust. Twice a day, the ground beneath our feet rises and falls by several centimeters or a couple of inches in a silent, planetary scale flexion. This solid Earth tide is a powerful reminder that we live on a dynamic and responsive world, constantly in gravitational conversation with its celestial partner. While the Moon's influence shapes our planet's surface, its own geology tells a story written in subtle, alien tremors. Our world shudders with the violent grind of tectonic plates, but the Moon speaks in a different language. It experiences moonquakes, seismic events that are a direct consequence of the tidal stresses exerted by Earth's unceasing gravitational pull. As our planet pulls and stretches the Moon's interior, its brittle crust groans and fractures, releasing seismic energy. These tremors, however, are unlike their terrestrial counterparts. On Earth, water and other materials in the rock quickly dampen seismic waves, but the Moon's dry, rigid structure allows them to ring like a bell. Consequently, a moonquake can persist for an astonishingly long time, sometimes lasting for up to 30 minutes, a silent, shuddering complaint against the gravitational tyranny of its larger companion. This internal activity exists in a world of stark contrasts, particularly in the shadowed realms of its poles. Here, in craters where the crater rims are so high and the angle of sunlight so low that the floors have not seen a single ray of direct sunlight in billions of years, we find one of the most valuable and surprising of lunar resources: water ice. These permanently shadowed regions are cosmic cold traps. Temperatures in these areas plummet to below minus 163 degrees Celsius, which is minus 262 degrees Fahrenheit, creating an environment where any water molecules, likely delivered by comets and asteroids over eons, become trapped and frozen solid. This ancient ice holds clues to the history of the solar system and represents a critical resource for any future human presence on the moon. The existence of these eternally dark places might lend credence to the popular notion of a dark side of the moon. But this phrase is a profound misnomer. The term more accurately describes the far side, the hemisphere that is permanently turned away from Earth due to tidal locking. This far side is not perpetually dark. It experiences the same cycle of day and night as the near side, a 2-week-long day followed by a 2-week-long night. It is only dark from our perspective, a hidden landscape that remained a complete mystery to humanity until we ventured into space. When we finally did venture there, we entered a realm governed by a different set of physical rules. Standing on the lunar surface, an astronaut experiences a profound lightness of being, a consequence of the moon's significantly weaker gravity. With a gravitational pull only about 1/6 that of Earth's, a person who weighs 180 pounds, or about 82 kilograms, on their home planet would feel as though they weighed a mere 30 pounds, or just under 14 kilograms. This feeble gravity transformed human movement into a surreal, bouncing ballet, with astronauts like Neil Armstrong and Buzz Aldrin taking bounding leaps across the desolate landscape. This extraordinary experience has been granted to a very select group of individuals. In the entire history of humanity, only 12 people have ever walked on the surface of another world, and all of them were American men, astronauts of the Apollo program, who made the perilous journey between 1969 and 1972. They were the first to witness firsthand the alien environment of the moon, an environment defined by its profound emptiness. This emptiness is due to the moon's lack of any substantial atmosphere. It possesses only a fragile, tenuous layer of gases known as an exosphere, so thin that the individual atoms and molecules rarely collide with one another. The practical consequences of this are deeply strange. Without a medium to transmit vibrations, the moon is a place of absolute silence. Explosions, landings, and rocket launches would occur without a sound. Furthermore, without an atmosphere to scatter sunlight, the sky is perpetually, inkily black, even when the sun is blazing overhead. Stars are not washed out by a blue sky. They remain sharp, cold points of light, visible right next to the sun's glaring disk. Yet, beneath this silent, seemingly inert surface, there are echoes of a more dynamic past. Modern, seismic, and gravitational data strongly suggest that the moon, much like our own planet, possesses a molten core. Deep within its center lies a zone of liquid iron and other elements, a lingering reservoir of the immense heat from its cataclysmic formation billions of years ago. This discovery challenges the old view of the moon as a simple, cold, dead rock, and paints a picture of a more complex and layered world. Our journey to understand this complexity began in earnest during the Cold War. The first emissary from Earth to reach the moon's vicinity was not human, but a 1.5 meter or 5 foot wide sphere of Soviet engineering. In January of 1959, the Soviet Union's Luna 1 probe became the first uncrewed mission to fly past the moon, a monumental achievement that marked a new era of exploration and signaled the start of a frantic technological race. This race, however, had a darker, more secretive side. In the 1950s, as the United States military contemplated ways to demonstrate its power on a global and even interplanetary stage, a startling and clandestine plan was developed. Known as Project A119, its official title was A Study of Lunar Research Flights. The project's secret objective was to detonate a nuclear bomb on the surface of the moon. The goal was not scientific. It was a geopolitical power play designed to create a flash of light so brilliant that it would be visible to the naked eye from Earth. A terrifying demonstration of American might. The project, which involved a young Carl Sagan, was ultimately abandoned, but it serves as a chilling reminder of how the heavens themselves were nearly drawn into the conflicts of Earth. Away from the high-stakes drama of the Cold War, the moon continues its serene and predictable journey across our sky. A journey that produces one of the most fundamental and observable of all celestial phenomena, the phases of the moon. This regular cycle, from new moon to full moon and back again, is not an intrinsic change in the moon itself, but a simple and elegant consequence of its position in orbit relative to the Earth and the Sun. As the moon travels around us, we on Earth see different portions of its sunlit hemisphere, creating the familiar progression of waxing crescents, quarter moons, and gibbous shapes that have been used to mark the passage of time by cultures around the world for countless generations. Even when the moon presents only a sliver of its sunlit face to us, the rest of its disk is not always lost in complete darkness. On a clear night, during the crescent phases, one can often see the dark portion of the moon glowing with a soft, ethereal light. This beautiful and subtle phenomenon is known as earthshine. It is, in essence, the reflection of a reflection. Sunlight streams past the moon, strikes the full face of the Earth, and bounces off our planet's clouds and oceans back into space, casting a ghostly illumination upon the lunar landscape. An astronaut standing on the night side of the moon would see a brilliant, fully illuminated Earth hanging in the black sky. A celestial beacon 5 times larger and dozens of times brighter than a full moon appears to us. This reflected glory from our own world paints the lunar night in a delicate, silvery glow. This faint light falls upon a surface with a peculiar and distinct aroma. When the Apollo astronauts returned to the confines of their lunar module after walking on the moon, they brought with them a fine coating of lunar dust on their suits and equipment. Once they removed their helmets, they were met with a surprisingly pungent and unforgettable smell. They consistently described it as the scent of spent gunpowder, a sharp, acrid odor that hung in the air of the small cabin. This smell is not from combustion, but is likely the result of the lunar dust's unique composition and its interaction with the oxygen suddenly present in the lander. The dust itself is made of tiny, sharp particles of rock and glass, created by billions of years of micro-meteorite impacts, and its reactive surfaces, having never been exposed to an atmosphere, may have readily oxidized, producing this distinctive and evocative scent. The men who first smelled this otherworldly dust were Neil Armstrong and Buzz Aldrin, the crew of Apollo 11. On July 20th, 1969, they became the first human beings to set foot on another world, a moment that stands as one of the most profound achievements in the history of civilization. Their landing was a culmination of a decade of intense effort, a technological and human triumph that captivated the globe. They were followed by 10 other astronauts in a series of missions that expanded our knowledge of the moon exponentially. The final human footsteps in the lunar dust were left by astronaut Gene Cernan, the commander of Apollo 17, in December of 1972. As he prepared to climb the ladder of the lunar module for the last time, he spoke words that acknowledged the temporary nature of this departure, expressing a hope that humanity would one day return. The world these astronauts explored is one of impressive scale. The moon's diameter, as previously noted, measures 3,475 kilometers, or about 2,159 miles. This makes it a substantial body, roughly a quarter the diameter of Earth itself. This is an unusually large ratio for a moon and its parent planet, leading some astronomers to refer to the Earth-Moon system as a double planet. The moon completes a full orbit around our planet in approximately 27.3 days. This period, known as the sidereal month, is the time it takes for the moon to return to the same position relative to the background stars. This steady, predictable cycle has formed the basis for countless calendars throughout human history, a celestial clockwork by which our ancestors marked the passage of seasons and the timing of festivals. Life on the surface of this orbiting world is a life of extreme temperatures, with no atmosphere to trap heat or distribute it around the planet. The lunar surface experiences a thermal roller coaster of epic proportions. When the sun is directly overhead at the lunar equator, the temperatures can soar to a blistering 127 degrees Celsius, which is 260 degrees Fahrenheit, well above the boiling point of water. But when the sun sets and the 2-week-long lunar night begins, the temperature plummets to a staggeringly cold minus 173 degrees Celsius, or minus 280 degrees Fahrenheit. Any future lunar inhabitants will need to engineer habitats capable of withstanding a temperature swing of 300 degrees Celsius, close to 540 degrees Fahrenheit, every single month. This hostile yet compelling world has been our companion since the very beginning. The moon is estimated to be approximately 4.6 billion years old, having formed in the chaotic aftermath of the giant impact shortly after the Earth itself had coalesced. This makes it a primordial relic, a witness to the entire history of our planet. Its ancient, cratered surface is a preserved record of the early solar system, a history book that has not been erased by the wind, water, and tectonic activity that constantly reshape the Earth. Our connection to this ancient body is so deep that we have given it a name that reflects its intimate presence in our lives. In English, we simply call it the moon, but its proper, formal name used in scientific and literary contexts is Luna, derived directly from the Latin. This name is the root of words like lunar and lunatic, a testament to the moon's long-held and powerful grip on the human imagination. While the near side, the face we call Luna, has been a familiar sight for all of human history, the far side remained a complete enigma. It was a true terra incognita until October 7th, 1959, when the Soviet Union's Luna 3 probe successfully flew around the moon and transmitted the first grainy images of its hidden hemisphere back to an astonished world. The pictures revealed a landscape starkly different from the near side. It was more heavily cratered and had far fewer of the large, dark maria that are so prominent on the face we see. This discovery posed new and fascinating questions about the moon's geological history and asymmetrical development. This asymmetry is a direct result of the moon's vulnerability. Lacking the protective shield of a substantial atmosphere or a global magnetic field, its surface is perpetually bombarded by the harsh realities of space. It is constantly scoured by the solar wind, a stream of charged particles flowing from the sun, and pelted by cosmic rays, high-energy particles from deep space. Most dramatically, it is under a constant rain of meteorites, from microscopic dust grains to large asteroids, which have sculpted its surface into the cratered landscape we see today. This relentless bombardment has pulverized the surface rock over billions of years, creating a thick layer of fine dust and debris known as regolith, the very material that holds the footprints of the Apollo astronauts, preserved in the silent, timeless vacuum. The stark, cratered landscape of the far side stands in dramatic contrast to the familiar face of the moon, a difference defined by the vast, dark plains that dominate the near side. Early astronomers, peering through primitive telescopes, mistook these smooth, dark patches for oceans and seas. They gave them romantic Latin names that have endured to this day. Mare Tranquillitatis, the Sea of Tranquility; Mar Imbrium, the Sea of Rains; and Oceanus Procellarum, the Ocean of Storms. We now know these are not bodies of water, but enormous, ancient basins of solidified lava. Known as Maria, the Latin word for seas, they were formed billions of years ago when massive asteroid impacts cracked the moon's crust, allowing molten rock from the mantle to well up and flood the low-lying basins. This dark, iron, rich basaltic rock cooled to form the relatively smooth surfaces that we see today. A stark, visual, and geological counterpoint to the older, more heavily cratered regions. These older regions are the lunar highlands. Brighter in color and far more rugged, the highlands are the moon's original primordial crust, composed mainly of a lighter rock called anorthosite. This ancient terrain is saturated with craters of all sizes, a testament to the intense bombardment that characterized the early history of the solar system, a period known as the Late Heavy Bombardment. The highlands represent the moon in its original, battered state, before the Great Maria were formed, offering a pristine window into the violent dawn of our cosmic neighborhood. The water that now lies frozen in the polar craters, a resource of immense future value, was likely not part of the moon's original inventory. The incredible heat of its formation would have boiled away any water present in the initial debris cloud. Instead, it is believed that this water was delivered to the moon over billions of years by a steady celestial rain of comets and asteroids. These icy bodies, remnants from the formation of the outer solar system, would have crashed onto the lunar surface, releasing their frozen water as vapor. While most of this vapor would have been lost to space, some of it would have migrated to the coldest parts of the moon, the permanently shadowed craters at the poles, where it accumulated as the deposits of ice we are now discovering. This cosmic coincidence of a tidally locked moon and an Earth-bound observer leads to one of nature's most inspiring spectacles: the total solar eclipse. The fact that the sun and the moon appear to be the same size in our sky is the linchpin of this phenomenon. It allows the moon's disk to perfectly obscure the sun's bright photosphere, creating a brief, artificial twilight, and revealing the sun's magnificent, ethereal corona. A halo of plasma that is normally invisible. This breathtaking alignment is a unique feature of our planet at this particular moment in its geological history. In the distant past, the moon appeared larger, and in the distant future, it will appear smaller, eventually becoming too small to ever completely cover the sun. The dust that blankets the lunar surface, the regolith, is a substance with a dangerous and deceptive nature. While it may look as soft as fine sand, its microscopic properties are perilous. Lunar dust is not weathered by wind and water like terrestrial dust. Instead, it is formed by the relentless impact of micrometeorites, which pulverize the rock into tiny, sharp, and abrasive particles, akin to microscopic shards of glass. This dust posed a significant challenge for the Apollo missions, clinging to everything, abrading spacesuits, clogging mechanisms, and causing overheating issues by coating surfaces designed to radiate heat into space. Its abrasive nature and potential to be inhaled make it one of the most significant environmental hazards for future lunar explorers. Among the items the Apollo astronauts intentionally and unintentionally left behind, a peculiar and very human collection remains. 96 bags filled with human waste, including urine and feces. These were jettisoned onto the lunar surface primarily to save weight for the return journey, a critical consideration when calculating the fuel needed to escape the moon's gravity and bring back precious samples of lunar rock. While seemingly mundane, these bags are now objects of significant scientific interest. Scientists are eager to one day retrieve them to study the long-term survival of microorganisms in the harsh radiation environment of space, a study that could have profound implications for our understanding of the limits of life. While the living were focused on returning to Earth, one man made a final, posthumous journey to the moon. Eugene Shoemaker, a renowned geologist and planetary scientist, was a pioneer in the study of impact craters and a key figure in training the Apollo astronauts. It was his lifelong dream to go to the moon himself, a dream that was thwarted by a medical condition. After his tragic death in a car accident in 1997, a portion of his ashes was placed aboard the Lunar Prospector probe. In 1999, at the end of its mission, the probe was deliberately crashed into a crater near the lunar South Pole. This act made Eugene Shoemaker the first, and to this day, the only human being to have their remains laid to rest on another celestial body, a fitting tribute to a man who dedicated his life to understanding them. The Apollo missions were not all science and survival. There were moments of levity and human spirit. During the Apollo 14 mission in 1971, astronaut Alan Shepard, an avid golfer, smuggled a makeshift 6-iron head and 2 golf balls aboard the lunar module. In the 1/6 gravity, he famously swung at the balls. The first shot was a shank, but the second connected cleanly. Encumbered by his stiff spacesuit, his swing was one-handed, but he sent the ball flying, in his own words, for miles and miles and miles. In reality, the low gravity and lack of air resistance meant the ball traveled for several hundred meters, or about a quarter of a mile, a uniquely lunar sporting achievement. A more scientific, but no less profound demonstration took place during the Apollo 15 mission. Commander David Scott performed a simple experiment to illustrate a fundamental principle of physics. He held out a geological hammer and a falcon feather and dropped them at the same time. On Earth, air resistance would have caused the feather to flutter slowly to the ground long after the hammer. But in the vacuum of the moon's exosphere, the 2 objects, one heavy and one light, fell at exactly the same rate and hit the lunar dust at the exact same instant. This elegant and televised experiment was a perfect demonstration of Galileo's principle of equivalence, proving that gravity accelerates all objects equally, regardless of their mass, in the absence of air. This moment beautifully encapsulated the spirit of the Apollo program, a journey of human exploration, grounded in the timeless pursuit of scientific understanding. The hostile surface environment of the Moon, with its extreme temperatures and radiation, presents a formidable challenge for future habitation. However, recent discoveries have revealed a potential solution. In the Moon's Mare Tranquillitatis region, the Sea of Tranquility, orbital probes have identified a series of deep pits, likely the collapsed ceilings of ancient lava tubes. These subterranean caverns offer a remarkably stable and protected environment. While the surface temperature swings by hundreds of degrees, data suggests that within these pits, the temperature remains at a comfortable and consistent 17 degrees Celsius, or about 63 degrees Fahrenheit. This stable, shirt-sleeve environment could provide a natural shelter for future lunar bases, shielding inhabitants from the hazards of the surface. These lunar pits, natural caves, carved by ancient volcanism, represent more than just a thermally stable environment. They are potential sanctuaries from the relentless dangers of the lunar surface. For any long-term human presence on the Moon, the greatest threats are not the temperature extremes, which can be engineered against, but the constant, invisible rain of radiation. The Moon has no global magnetic field to deflect the solar wind, and no atmosphere to absorb the high-energy cosmic rays that stream in from deep space. A person standing on the lunar surface would be exposed to radiation levels hundreds of times higher than on Earth, dramatically increasing their lifetime risk of cancer and other health issues. Furthermore, the surface is constantly bombarded by micrometeorites, tiny particles traveling at speeds of thousands of kilometers per hour. While individually small, their cumulative effect can degrade equipment and even pose a threat to the integrity of a spacesuit. The lunar pits, however, offer a ready-made solution. A habitat placed within one of these caverns, or at the bottom of a pit, would be shielded by a thick, natural roof of solid rock, providing near-total protection from all of these hazards. This discovery has transformed our thinking about lunar colonization, shifting the focus from building surface structures to exploring and utilizing these subterranean havens. The very existence of the Moon, this celestial shield and partner, is tied to a ghost from our planet's distant past. The giant impact theory posits that a Mars-sized protoplanet, Theia, collided with the early Earth. For a long time, this remained a compelling but largely unproven hypothesis. However, recent advances in seismology have revealed a tantalizing piece of evidence deep within our own planet. Scientists have discovered two enormous, continent-sized blobs of rock in Earth's lower mantle, one beneath Africa and the other beneath the Pacific Ocean. These structures, known as large, low-shear velocity provinces, are denser and chemically different from the surrounding mantle. One compelling theory suggests that these are the remnants of Theia itself. In this scenario, the impact was so violent that Theia's dense iron core and parts of its mantle plunged deep into Earth, sinking through our planet's own molten interior to finally come to rest at the boundary with the core. If this is true, then the very body that created our moon has been buried within our world for 4.5 billion years. A secret and silent testament to our planet's cataclysmic birth. While we can now probe the deep interior of our own world, we have also come to understand the near-total vacuum that exists on the moon. Its exosphere is so thin that it is functionally a void. This lack of air means that astronauts must be entirely self-contained, relying on sophisticated spacesuits for their very survival. These suits are not merely clothing. They are personal, miniaturized spacecraft. They provide a pressurized, oxygen-rich atmosphere to breathe, regulate temperature against the savage heat and cold, shield against radiation, and protect against micrometeorite impacts. Without this remarkable technology, a human on the lunar surface would be exposed to a hard vacuum, causing the moisture in their lungs and on their skin to boil away instantly. A swift and certain death. The moon they explored was once a much closer neighbor. In the immediate aftermath of its formation, the moon was not the distant object we see today. It is estimated to have been about 10 times closer to the Earth, hanging in the primordial sky as a monstrous, looming disk. At this proximity, its gravitational influence would have been immense, creating colossal tides in Earth's early magma oceans and producing a day that was only a few hours long. Over the eons, the same tidal forces that have slowed Earth's rotation have also pushed the moon further away, a process that continues to this day. The rate at which the moon is receding, about 3.8 centimeters, or 1.5 inches per year, is, by a curious coincidence, comparable to the rate at which human fingernails grow. This slow, inexorable drift is a constant and measurable process, a silent, cosmic ballet that has been unfolding for billions of years. The primary engine of this cosmic dance is the moon's gravitational pull on Earth's oceans, which creates the twice-daily high and low tides. This tidal interaction acts as a brake on Earth's rotation, gradually slowing our planet down and lengthening our days. The energy lost by the spinning Earth is transferred to the moon, boosting it into a higher and more distant orbit. This gravitational partnership is therefore not just about tides. It is about a fundamental exchange of angular momentum that has shaped the evolution of both worlds. The profound influence of the moon's gravity extends beyond the oceans to the very stability of our planet's climate. Earth spins on an axis that is tilted at an angle of about 23.5 degrees relative to its orbit around the Sun. This axial tilt is the reason we have seasons. The gravitational pull of the large, relatively close Moon acts like a stabilizing gyroscope, preventing this tilt from wobbling erratically over long periods. Without the Moon's steadying influence, scientists believe Earth's axial tilt could vary chaotically, swinging from 0 to as much as 85 degrees. This would lead to catastrophic climate shifts, with the poles sometimes pointing directly at the Sun for years on end, creating extreme and unpredictable conditions that would have made it far more difficult, if not impossible, for complex life to evolve. In a very real sense, the Moon has served as a climatic anchor, helping to make Earth the habitable world it is today. While the Moon's gravitational and magnetic influence is now dominated by its relationship with Earth, it once possessed a magnetic field of its own. When the Apollo astronauts brought back lunar rocks, scientists were stunned to discover that some of them were magnetized. This was a profound mystery, as the Moon today has no global magnetic field. The solution lies in its ancient past. For the first 1 to 2 billion years of its existence, the Moon's molten iron core was likely convecting vigorously enough to generate a dynamo, creating a protective magnetic shield similar to, though weaker than, Earth's. As the Moon cooled and its core solidified, this dynamo eventually died, and the magnetic field vanished. However, the rocks that formed on the surface during that active period retained a record of the ancient field, a residual magnetism that serves as a fossilized remnant of the Moon's more dynamic youth, a ghostly echo of a magnetic field that has been dead for billions of years. The naming of the features on this ancient, magnetized world follows a rich tradition that blends science and history, creating a celestial map of human intellectual achievement. The craters, mountains, and valleys that scar the Moon's surface are not given random or whimsical names. By a convention established in the 17th century and now overseen by the International Astronomical Union, these features are named in honor of distinguished scientists, artists, and explorers who have made significant contributions to human knowledge. Thus, the lunar landscape is a vast, silent memorial. We see craters named for Copernicus and Kepler, the astronomers who revolutionized our understanding of the solar system; for Plato and Aristotle, the foundational thinkers of Western philosophy; for Leonardo da Vinci, the archetypal Renaissance man; and for Marie Curie, a pioneer in the field of radioactivity. This practice transforms the Moon into a pantheon of intellectual giants, their names etched into the very fabric of another world, a permanent tribute to their legacy. Among these millions of named and unnamed craters, one stands out for its sheer scale and significance. The South Pole Aitken Basin, located on the far side of the Moon, is a feature of almost unimaginable proportions. It is the largest and oldest recognized impact basin on the Moon, and one of the largest in the entire solar system, stretching approximately 2,500 kilometers or 1,600 miles in diameter and plunging to depths of more than 13 kilometers or 8 miles. It is a colossal scar from the solar system's early, violent history. The impact that created this basin was so powerful that it is thought to have dredged up material from the moon's deep crust and possibly even its upper mantle. For this reason, it is a prime target for future robotic and human missions, as samples from this region could provide an unprecedented look into the deep interior of the moon, revealing fundamental secrets about its composition and formation. Within this giant basin, and in other craters near the poles, lie some of the most intriguing and mysterious places on the lunar surface. These are the permanently shadowed craters, regions that, due to the moon's slight axial tilt, have remained in perpetual darkness for billions of years. The floors of these craters are among the coldest places in the solar system, with temperatures dropping low enough to trap not just water ice, but other volatile compounds that would otherwise be vaporized by sunlight and lost to space. These cosmic cold traps are pristine repositories of ancient materials, preserving a chemical record of the comets and asteroids that have impacted the moon over eons. They are time capsules that could tell us about the composition of the early solar system and the delivery of the building blocks of life to the inner planets. The sky above this alien landscape is a sight of stark and absolute beauty. Because the moon has no significant atmosphere to scatter sunlight, the sky is not blue, but an eternal, unending black. The transition from day to night is not a gradual process of twilight, but an instantaneous switch as the sun's disk slips below the horizon. Against this profound blackness, the sun, the earth, and the stars shine with a brilliant, unwavering clarity, unhindered by the shimmering and distortion caused by an atmosphere. This perfect viewing condition makes the moon the ultimate platform for astronomy, a place where a telescope could observe the universe with a sharpness and depth that is impossible to achieve from the surface of the Earth. The ground beneath this perfect sky is covered by a thick blanket of dust and fragmented rock, a layer known as regolith. This material is the product of 4.5 billion years of relentless micrometeorite bombardment, which has pulverized the surface rock into a fine, soil-like substance. The lunar regolith is not like terrestrial soil. It contains no organic matter and has never been weathered by wind or water. It is composed of sharp, abrasive particles, glassy spherules from melted impact debris and rock fragments. Its depth varies across the moon from just a few meters, or about 10 feet, in the younger Maria, to tens of meters, or over 60 feet, in the ancient highlands. This pervasive layer is the interface between the solid moon and the vacuum of space, a complex and scientifically rich material that holds clues to the history of the sun and the galaxy. The extreme temperature fluctuations on the lunar surface are a direct result of this combination of a vacuum and a dusty, insulating surface layer. During the long, 2-week lunar day, the regolith absorbs the intense solar radiation, heating up to temperatures well above the boiling point of water. However, as soon as the sun sets, this heat is rapidly radiated away into the blackness of space. With no atmosphere to act as a thermal blanket and trap the warmth, the temperature plummets dramatically, creating one of the most severe thermal environments in the solar system. This constant, extreme cycle of heating and cooling causes the surface rocks to expand and contract, a process of thermal stress that, over billions of years, contributes to the slow erosion and breakdown of the lunar surface, a silent, patient form of weathering in a world without weather. On a clear, dark night from Earth, the full moon appears as the brightest object in the sky, a beacon that can seem almost blindingly brilliant. Yet this perceived brightness is relative. When measured, the full moon is approximately 14,000 times brighter than the faintest stars that are visible to the naked human eye. However, this pales in comparison to the sun, which is about 400,000 times brighter than the full moon. The moon's brilliance is simply a reflection, a pale ghost of the sun's true power. Yet it is enough to dominate our night sky and cast shadows on the ground, a constant and powerful reminder of our closest celestial neighbor. This neighbor holds a unique distinction in the annals of human endeavor. The moon is, and for the foreseeable future will remain, the only celestial body besides Earth that has ever been visited by human beings. Between 1969 and 1972, the 6 Apollo landings brought 12 men to its surface. This brief, extraordinary period of exploration represents a singular achievement, a moment when humanity stepped off its home world and walked upon another. The scientific return from these missions was monumental, but their cultural and psychological impact was perhaps even greater, forever changing our perspective of our own planet, a fragile, blue marble hanging in the vast, silent void. The legacy of these missions is not just in memories and photographs, but in the tangible pieces of another world they brought back. The Apollo astronauts collected and returned a total of 382 kilograms, or 842 pounds, of lunar rocks, core samples, pebbles, sand, and dust from the lunar surface. These samples, collectively known as the Lunar Sample Suite, have been a scientific treasure trove for over 5 decades. They have been meticulously studied by scientists around the world, providing profound insights into the moon's origin, age, and geological history. Kept in pristine condition at the Lunar Sample Laboratory Facility in Houston, Texas, these rocks from another world are a physical link to our brief visits to the moon and continue to yield new discoveries as our analytical techniques improve. The specialized field of science dedicated to the study of the moon's geology, its structure, composition, and history is known as selenology, derived from Selene, the Greek goddess of the moon. This discipline is the lunar equivalent of terrestrial geology. Selenologists study the data from orbital probes, the seismic readings from the instruments left behind by the Apollo missions, and most importantly, the precious lunar samples to piece together the 4.5 billion year story of our celestial companion. It is a field that has transformed the moon from a mythical object in the sky into a complex and understandable world. A world with a violent past and a quiet, but not entirely inactive, present. The first human explorers to set foot on this alien geological landscape landed in a place that has since become iconic, a name synonymous with one of humanity's greatest achievements. The Apollo 11 mission, carrying Neil Armstrong and Buzz Aldrin, touched down in a region of the moon known as the Sea of Tranquility, or Mare Tranquillitatis. This name was chosen not for any scientific reason, but for its poetic and aspirational quality, reflecting the peaceful intent of the mission. It is a vast, dark, basaltic plain, a classic example of the lunar Maria, formed by ancient lava flows. The specific landing site, designated Tranquility Base, is now a historic landmark, a small patch of a distant world where humanity first stepped beyond its cradle. The legacy of that first step, and the 11 others who followed, is preserved in the most remarkable and fragile of ways. The footprints left behind by the Apollo astronauts in the fine lunar regolith remain there to this day, and they are likely to endure for millions of years. On Earth, such impressions would be erased in moments by wind or rain. But the moon has no weather. There is no wind to blow the dust around, no water to wash it away. In the silent, unchanging vacuum of space, these footprints, along with the tracks of the lunar rovers and the discarded descent stages of the lunar modules, are frozen in time, a silent, ghostly monument to a brief period of human presence. They will remain undisturbed until they are either visited again or are slowly, almost imperceptibly, sand-blasted away by the relentless, eons-long process of micrometeorite bombardment, a cosmic erosion so slow it is almost eternal. The celestial body that holds these footprints is not the perfect sphere of ancient Greek philosophy. Detailed measurements have revealed that the moon is slightly flattened, making it what is known as an oblate spheroid. It bulges slightly at its equator and is compressed at its poles. This shape is a result of the rotational forces that were at play when the moon was still a molten, malleable body billions of years ago. Although it is now tidally locked and rotates very slowly, this subtle flattening is a fossilized remnant of its more dynamic, faster-spinning youth. A shape that was frozen into its crust as it cooled and solidified. Adding to this physical asymmetry is a curious and significant gravitational anomaly: the moon's center of mass. The gravitational balance point of the entire body is not located at its geometric center. Instead, it is offset by approximately 2 kilometers, or about 1.2 miles, shifted from the geometric center in the direction of the Earth. This offset is likely a consequence of the way the moon formed and the uneven distribution of mass in its crust and mantle. The lunar crust, for instance, is known to be significantly thicker on the far side than it is on the near side. This gravitational imbalance plays a crucial role in maintaining the moon's tidal lock, ensuring that its heavier side is perpetually drawn toward our planet, a permanent and lopsided gravitational embrace. This powerful, ever-present companion has not only shaped our planet, but also our language and our folklore. The word lunatic, for example, is a direct descendant of the Latin word for the moon, luna. It stems from the ancient and persistent belief found in many cultures that the full moon could induce madness, a condition referred to as lunacy. While this belief has been thoroughly debunked by modern science, the word remains in our vocabulary as a linguistic artifact, a reminder of a time when the moon was seen not just as a physical object, but as a powerful, mystical force capable of influencing human minds and destinies. The idea of the moon as a destination for travel, a place that could be visited, has an equally long and rich history. Long before the science of rocketry made such a journey possible, the moon was a canvas for the human imagination. The first known work of fiction to describe a journey to the moon was written not in the era of science fiction, but in the 2nd century by a Greek-speaking Syrian satirist named Lucian of Samosata. In his story, appropriately titled A True Story, the protagonist and his crew are swept up to the moon by a giant whirlwind, where they encounter a bizarre society of moon dwellers and become embroiled in an interplanetary war. While intended as a satire of the tall tales of his time, Lucian's work is a remarkable early example of the genre we now call science fiction, the first imaginative leap from our world to another. Centuries later, as our scientific understanding grew, so too did our ability to map and catalog the moon's features. The first truly detailed map of the moon, the one that established the system of nomenclature we still use today, was created in 1651 by 2 Italian astronomers and Jesuit priests, Giovanni Riccioli and Francesco Grimaldi. It was Riccioli who introduced the practice of naming the craters after famous astronomers and scientists, and Grimaldi who gave the dark plains their poetic sea-related names. Their map was a landmark achievement, transforming the moon from a mysterious, mottled orb into a charted territory, a world with named places and identifiable features, a destination that could be studied and, one day, perhaps visited. Despite this growing scientific familiarity, the moon retains its power to deceive our senses. One of the most enduring and perplexing optical illusions is the moon illusion, the phenomenon in which the moon appears to be significantly larger when it is near the horizon than when it is high in the sky. This is purely a trick of our perception. The moon's actual size in the sky does not change. Scientists still debate the exact cause, but the leading theory suggests it is a cognitive illusion related to how our brains perceive distance. When the moon is near the horizon, we see it in context with familiar terrestrial objects like trees and buildings, and our brain interprets it as being very far away and therefore enormous. When it is high in the sky, it is isolated in the vastness of space, with no depth cues, and our brain perceives it as being closer and therefore smaller. It is a powerful reminder that even our most direct observations of the cosmos are filtered through the complex and often fallible instrument of the human mind. The moon's cultural significance is as vast as its scientific importance, with different civilizations weaving it into their mythologies in unique ways. In the cosmology of ancient Greece, the moon was personified as the goddess Selene. She was often depicted as a beautiful woman with a pale face, driving a silver chariot pulled by 2 horses across the night sky. She was a figure of romance and mystery, the sister of Helios, the sun god, and Eos, the goddess of the dawn. This personification of the moon as a divine being is a common thread in human history, reflecting the deep and universal need to find meaning and create stories about the silent, luminous companion that graces our night sky. Our modern lexicon of the sky contains echoes of these ancient myths and a host of newer, more colloquial terms that describe the moon's appearance and behavior. One of the most famous of these is the blue moon. This term has nothing to do with the moon's actual color, but refers to a specific and relatively rare calendrical event, the occurrence of a second full moon within a single calendar month. Because the lunar cycle is about 29.5 days long, which is slightly shorter than the average length of a calendar month, it is possible, every 2 to 3 years, for 2 full moons to be squeezed into the same month. This second full moon is the one we call a blue moon, a phrase that has become a popular metaphor for a rare event, as in the expression, "once in a blue moon." Another, more visually dramatic phenomenon is the supermoon. This occurs when the full moon coincides with its closest point to Earth in its monthly orbit, a point known as perigee. The moon's orbit is not a perfect circle, but an ellipse, so its distance from Earth varies by about 50,000 kilometers, or roughly 30,000 miles, throughout the month. When the full moon happens to occur at its closest approach, it can appear up to 14% larger in diameter and 30% brighter than a full moon at its farthest point, or apogee. While this difference can be subtle to a casual observer, for dedicated sky gazers, a supermoon is a spectacular sight. A night when our celestial companion seems unusually large and luminous. The celestial mechanics that give us these phenomena can also produce one of the most sublime and beautiful events in the night sky: a lunar eclipse. This occurs when the Earth passes directly between the sun and the moon, casting a shadow that darkens the lunar surface. For a lunar eclipse to happen, the sun, Earth, and moon must be perfectly aligned, a configuration known as syzygy, as the moon glides into Earth's shadow. It does not simply vanish from view. Instead, it is often bathed in a soft, coppery red glow. This eerie and beautiful coloration has earned it the ominous nickname blood moon. The red hue is caused by sunlight that is filtered through Earth's atmosphere. As sunlight passes through our atmosphere, the blue light is scattered away, the same reason our sky is blue, while the red light is bent or refracted into the Earth's shadow. This faint, reddish light then illuminates the eclipsed moon, turning it into a ghostly crimson orb. This gravitational alignment of sun, Earth, and moon is a constant, dynamic interplay that has had a profound effect on the evolution of our own planet. The moon's gravitational pull on Earth is the primary force that is gradually slowing down our planet's rotation. Every day, the tides raised by the moon create a frictional drag on the Earth, acting like a gentle but persistent brake. Billions of years ago, a day on Earth was much shorter, perhaps only 6 to 12 hours long. Over geological time, the moon's tidal braking has lengthened the day to the 24 hours we are familiar with today. This process continues, and our days are still getting longer, although at an incredibly slow rate of about 1.8 milliseconds per century. This means that in about 200 million years, a day on Earth will be approximately 25 hours long, a slow and inexorable change driven by our constant companion. Despite the poetic names of its seas and the evidence of frozen water in its polar craters, there is no liquid water anywhere on the surface of the moon. The atmospheric pressure is so low, essentially a vacuum, that liquid water cannot exist. If you were to pour a glass of water onto the lunar surface, it would not form a puddle. It would instantly and violently boil away, with the resulting vapor being lost to space, while any remaining droplets would simultaneously freeze solid. The only places where water can persist are in the form of ice, hidden away in the permanent shadows of the polar craters where the sun never shines, and the temperature is cold enough to keep it perpetually frozen. The landscape where this water is trapped is one of dramatic and alien beauty, a world of stark contrasts. The surface of the moon is characterized by a rugged topography of craters, mountains, and valleys, all sculpted by the relentless history of asteroid and comet impacts. Unlike Earth, where mountains are primarily formed by the collision of tectonic plates, the mountains on the moon are almost exclusively the rims of ancient, giant impact basins. These circular mountain ranges, some soaring to incredible heights, encircle the vast, dark Maria, standing as silent monuments to the colossal impacts that shaped the moon's face billions of years ago. Some of these lunar mountains reach elevations that rival or even exceed the highest peaks on Earth. The tallest mountains on the moon are found in the rugged highlands, with some peaks reaching over 10,000 meters, or more than 33,000 feet, in height. This is significantly taller than Mount Everest, which stands at 8,848 meters, or 29,031 feet, above sea level. These lunar peaks can achieve such heights because the moon's weaker gravity puts less stress on the crust, allowing for more dramatic and taller geological formations to remain stable over geological time. The geological processes that shape our world, such as volcanism, erosion, and mountain building, are largely driven by a process known as plate tectonics, the movement of large, rigid plates that make up the Earth's crust. The moon, however, does not have plate tectonics. Its crust is a single, solid, and ancient shell that has not been broken up into moving plates. This is why its surface is so old and so well preserved. There is no subduction to recycle old crust, and no continental drift to rearrange the land masses. The moon is a geologically quiet world, a one-plate planet whose surface features are a direct and largely unaltered record of its 4.5 billion year history. This geological quiescence has led to a notable and significant asymmetry in the moon's structure. The crust on the near side of the moon, the face that is tidally locked with Earth, is significantly thinner than the crust on the far side. On average, the near side crust is about 50 kilometers, or 30 miles, thick, while the far side crust can be up to 100 kilometers, or 60 miles, thick. Scientists believe this difference is related to the way the moon cooled and solidified after its formation, with the gravitational pull and radiant heat of the nearby Earth playing a major role. This thicker far side crust acted as a barrier, preventing the molten magma from the mantle from easily reaching the surface, which is why there are far fewer Maria on the far side of the moon, resulting in its more ancient and heavily cratered appearance. The thin and fragile atmosphere that clings to this geologically quiet world is a mere ghost of an atmosphere, composed of a bizarre and tenuous mix of elements. Unlike Earth's dense blanket of nitrogen and oxygen, The moon's exosphere is a near-perfect vacuum containing trace amounts of unusual gases, including sodium and potassium. These elements are not primordial remnants from the moon's formation, but are actively being supplied to the atmosphere today. They are thought to be sputtered off the lunar surface by the impact of micrometeorites and the constant bombardment of the solar wind, which dislodge individual atoms from the surface rocks and send them bouncing into the exosphere. This delicate atmospheric veil is so thin that it is quickly stripped away by solar radiation pressure, meaning it must be continuously replenished. A fragile equilibrium between supply and loss that plays out in the silent vacuum. This tenuous atmosphere is a direct consequence of the moon's current geological state. For all practical purposes, the moon is considered geologically dead, or at least very nearly so. The massive volcanic eruptions that filled the Maria with lava ceased over 1 billion years ago. And since then, the moon's interior has cooled significantly. While there is evidence of some relatively recent, small-scale volcanic activity, and the moonquakes reveal that its interior is not completely inert, the era of major geological upheaval is long past. The moon no longer has the internal heat required to drive large-scale volcanism or plate tectonics, the very processes that keep the Earth's surface young and dynamic. This geological silence means the moon's surface is an ancient museum, preserving a record of impacts that on Earth would have been erased long ago. While the era of human visits was brief, our exploration of the moon has never truly ceased. In addition to the 6 crewed Apollo missions, the moon has been the destination for numerous robotic spacecraft sent by several nations. Probes like the Lunar Reconnaissance Orbiter from the United States have created incredibly detailed, high-resolution maps of the entire lunar surface, revealing its geology and topography in stunning detail. Landers and rovers from the Soviet Union, China, India, and Japan have touched down on its surface, analyzing the soil and rocks in situ. These robotic emissaries have vastly expanded our knowledge, acting as our remote eyes and hands, continuing the scientific exploration of our nearest celestial neighbor. This new era of exploration is truly international. Today, several countries are actively engaged in ambitious lunar exploration programs, signaling a global resurgence of interest in the moon. China, in particular, has had a series of remarkable successes with its Chang'e program, which has included orbiters, landers, rovers, and a historic sample return mission that brought back the first new lunar material in over 4 decades. India's Chandrayaan program has also achieved significant milestones, including placing an orbiter around the moon and making important discoveries about the distribution of water ice. These efforts, along with those of the United States, Russia, Japan, and the European Space Agency, are paving the way for a more sustained and collaborative future of lunar science and exploration. The ultimate goal of many of these new programs extends beyond simple exploration. The next great leap in our relationship with the moon is to establish a permanent, or at least long-term, human presence on its surface. Agencies like NASA, with its Artemis program, are working to build the rockets, spacecraft, and life support systems that would allow astronauts to live and work on the moon for extended periods. This endeavor is not just about revisiting the achievements of Apollo. It is about building a sustainable outpost, a scientific research station, and a potential staging point for future missions to Mars and beyond. A lunar base would allow for continuous scientific research in a unique environment and would drive the development of technologies needed for humanity to become a truly multi-planetary species. One of the key drivers for establishing this permanent presence is the potential to utilize the moon's natural resources. The moon is not just a barren rock. It is a potential source of valuable materials that could support a lunar economy and fuel future exploration. The most talked about of these is helium-3, a light, non-radioactive isotope of helium that is extremely rare on Earth, but is thought to be relatively abundant in the lunar regolith. It has been deposited there over billions of years by the solar wind. Helium-3 is a potential fuel for nuclear fusion reactors, a clean and powerful form of energy production that scientists have been pursuing for decades. If fusion power becomes a reality, the moon could become the Persian Gulf of the solar system, a vital source of clean energy for the Earth. The unique environment of the moon also makes it an unparalleled location for astronomical observatories. The absence of a thick atmosphere means that telescopes on the lunar surface would have a perfectly clear, undistorted view of the universe across the entire electromagnetic spectrum. Ground-based telescopes on Earth are limited by the blurring effects of the atmosphere and are completely blind to certain wavelengths of light that are blocked by it. A lunar telescope would have none of these limitations, offering a view as clear as that of the Hubble Space Telescope, but with the advantage of a stable, solid platform on which to build instruments of enormous size. Furthermore, the far side of the moon is the most radio-quiet location in the inner solar system, permanently shielded from the constant radio chatter of Earth, making it the perfect place to build a radio telescope to listen for the faint whispers from the early universe. Beyond its potential for future discoveries, the moon serves as a natural laboratory for studying the history of our solar system. Its ancient, unchanging surface is a perfectly preserved chronicle of the conditions that existed billions of years ago. The craters themselves are a direct record of the size and frequency of asteroid and comet impacts over time, providing a crucial baseline for understanding the bombardment history of all the inner planets, including Earth. The lunar rocks and soil contain a record of the sun's activity, a history of the solar wind embedded in the regolith like a 4 billion-year-long data tape. By studying the moon, we are, in a very real sense, studying the history of our own cosmic backyard, a history that has been almost entirely erased on our own geologically active planet. Ultimately, the moon is not just a satellite. It is a critical component in the complex system that makes Earth a habitable world. Its role in stabilizing our planet's axial tilt, which provides for a stable climate, is a profound and often overlooked contribution. Without the moon, the Earth's climate would be far more erratic and extreme, likely hindering the development and survival of complex life. The moon's gravity has also played a role in shaping the orbital environment of Earth, its presence helping to sweep up or deflect some of the space debris that might otherwise have impacted our planet. In this sense, the moon has acted as both a climatic anchor and a gravitational shield. This intimate relationship, this gravitational partnership, has been essential for maintaining a stable environment in which life on Earth could arise, evolve, and thrive. The moon, therefore, is not just a beautiful object in our night sky. It is a fundamental part of the story of life on Earth, a silent, cratered partner that has made our own world a more stable and hospitable place. The global effort to return to the moon and unravel its remaining secrets reached a historic milestone in 2019, when China's Chang'e 4 mission achieved a monumental first. It became the first spacecraft in history to successfully perform a soft landing on the far side of the moon. This hemisphere, permanently hidden from Earth, had been photographed by orbiters, but never before explored on the ground. The landing in the vast South Pole Aitken Basin was a remarkable technological feat, as it required a dedicated relay satellite positioned far beyond the moon to communicate with the lander and its rover, Yutu-2. This mission opened up a new frontier in lunar exploration, allowing scientists to study the unique geology of the far side directly, a region believed to hold fundamental clues about the moon's early history and the cataclysmic impact that shaped it. Probing even deeper than this historic landing, seismic data collected by the instruments left by the Apollo astronauts and reanalyzed with modern techniques has given us a clearer picture of the moon's deep interior. We now have strong evidence that the moon has a layered internal structure, much like Earth's, albeit on a smaller scale. At its very center lies a solid inner core, composed primarily of iron, with a radius of about 240 kilometers, or roughly 150 miles. Surrounding this solid heart is a liquid outer core, also mostly iron, which extends out to a radius of about 330 kilometers, or 205 miles. This discovery of a partially molten core was a revelation, confirming that the moon is not a cold, inert body works the way through, but still retains a significant amount of its primordial heat. The gravitational environment in which this layered moon exists is far more complex than a simple two-body dance with the Earth. Over the vast timescales of the solar system, the gravity of the planet Jupiter has had a significant and measurable influence on the Moon's orbit. As the largest planet in the solar system, Jupiter's immense gravitational pull perturbs the orbits of all other bodies, including the Earth-Moon system. These subtle but persistent tugs have, over billions of years, altered the shape and orientation of the Moon's orbit in complex ways. Understanding these long-term gravitational interactions is crucial for accurately modeling the past and future evolution of the Moon's trajectory and its relationship with Earth, a celestial dance choreographed not just by one partner, but by the entire solar system. As we have mapped and named the great features of the Moon, a special convention has been reserved for the craters located near its poles. These craters, many of which are home to the permanently shadowed regions containing water ice, are named in honor of deceased polar explorers from Earth's history. This fitting tribute connects the exploration of our own planet's most remote and challenging frontiers with the exploration of these new frontiers on another world. Thus, near the lunar poles, you will find craters named for Roald Amundsen, the first person to reach the Earth's South Pole, and Robert Peary, one of the first to reach the North Pole. It is a poignant link, honoring the courage and spirit of those who pushed the boundaries of exploration on Earth by etching their names into the landscape of our next great exploratory destination. The light that illuminates these polar craters, and indeed the entire lunar surface, travels across the void of space at the ultimate cosmic speed limit. The average distance between the Earth and the Moon is about 384,400 kilometers, or 238,900 miles. Traveling at the speed of light, which is approximately 300,000 kilometers per second, or 186,000 miles per second, the sunlight that reflects off the Moon's surface takes only about 1.3 seconds to complete its journey to our eyes. This means that when we look at the Moon, we are not seeing it as it is in that instant, but as it was 1.3 seconds in the past. It is a small but profound reminder that all of our observations of the universe are, in fact, observations of history. In this ancient, vacuum-sealed environment, some of the atmospheric phenomena we take for granted on Earth are completely absent. Mars is famous for its planet-encircling dust storms, massive weather events that can shroud the entire globe in a reddish haze for weeks. The Moon, however, has no global dust storms. While the electrically charged lunar dust can be levitated a few meters above the surface by electrostatic forces, a phenomenon observed by the Apollo astronauts as a strange lunar twilight. There is no wind to whip this dust into a frenzy. The lunar surface is a place of profound stillness, where the dust settles and remains undisturbed for geological ages, moved only by the impact of meteorites or the boots of visiting astronauts. The evidence of these countless impacts is not just found in the craters themselves. but is embedded within the very soil. Scattered throughout the lunar regolith are countless tiny, glittering glass beads. These spherules were formed when meteorites, traveling at hypersonic speeds, struck the moon's surface. The immense energy of these impacts instantly melted the target rock, splashing tiny droplets of molten silica into the vacuum. With no atmosphere to slow them down or alter their shape, these droplets cooled and solidified in flight, forming perfect, microscopic spheres of glass. The Apollo astronauts were captivated by these glassy beads, which ranged in color from clear to yellow, red, and even green and black, depending on their mineral composition. They are microscopic fossils of the violent impacts that have defined the moon's history. The moon's profound influence on Earth extends to the very length of our day. Without the moon, our planet would spin much faster. The tidal braking that has slowed our planet's rotation from its primordial speed would be absent, except for a much weaker tidal effect from the sun. Models suggest that without the moon, a day on Earth might be only 6 to 12 hours long. This rapid rotation would create radically different weather patterns, with much higher wind speeds and more frequent violent storms. The familiar rhythms of life, which are so closely tied to the 24-hour day-night cycle, would have evolved in a completely different, much more frenetic environment. In this sense, the moon has acted as a cosmic clock, gradually slowing time and creating the stable, predictable daily cycle that life has adapted to over eons. While the moon itself has no weather, its light can, on rare occasions, create a beautiful and ethereal atmospheric phenomenon here on Earth. A moonbow, or lunar rainbow, is formed in the same way as a normal rainbow, but the light source is not the sun, but the moon. It requires a specific set of conditions: a nearly full moon, a dark sky, and the presence of water droplets in the air, usually from rain or the mist of a waterfall. Because moonlight is so much fainter than sunlight, moonbows are much dimmer and often appear to the human eye as a ghostly white arc. However, long exposure photography can reveal their true faint colors. They are a rare and magical intersection of celestial light and terrestrial atmosphere, a rainbow born of the night. From its violent birth to its silent, steady presence in our sky, the moon continues to be a source of profound scientific discovery and deep cultural inspiration for all of humanity. It is both a destination and a mirror, a place that we have visited and a lens through which we have come to better understand our own planet and our place in the universe. It is a history book, a resource for the future, a stabilizer of our climate, and a beacon in our night. The story of the moon is inextricably linked to the story of Earth, a silent, cratered partner that has shaped our past and will undoubtedly play a crucial role in our future, a constant source of wonder that continues to pull not just on our oceans, but on our curiosity and our dreams. And so, our journey across the ancient, silent surface of the moon finds its gentle close. We have drifted through its history, from a cataclysmic birth in fire and chaos to the profound stillness of its present. It is more than just a rock, more than a light in the dark. It is our planet's anchor, a timeless witness to the unfolding of our own world, a silent partner in the long, slow dance of the cosmos. That same silver light, that same quiet companion, now watches over you as you prepare for rest. Let the vastness of its story and the profound quiet of its landscape guide your mind away from the noise of the day. There is nothing left to do but to let go. Feel the gentle, gravitational pull of slumber, a force as natural and as constant as the tides. Let your thoughts become weightless, drifting on a slow and steady orbit into the deep, dark expanse of your own dreams. Rest now, wrapped in the quiet of the cosmos. Sleep deeply and peacefully under the watchful gaze of our constant, silent moon.